Welcome to 5G Technology World. I'm site editor Martin Rowe. Today we are speaking with Professor Alex Wyglinski of Worcester Polytechnic Institute. Professor Wyglinski is a specialist in wireless communications, and he's going to tell us about some of the projects that they're working on, as well as his 5G work, specifically with how IoT devices are connecting to a 5G network. And he's also going to tell us a little bit about a millimeter wave lab that he has built in his backyard. So, Professor Wyglinski, thank you for coming on 5G Technology World. So, Professor, thank you for being with us today, and let's get started. So, 5G works. I mean, the designs work. But that doesn't mean that research ends, because just because something works doesn't mean it can't be improved. Mm-hmm. So what kind of work is being done in terms of looking to improve 5G? For example, in terms of cost, heat, power consumption, spectral efficiency, size, or weight. So what kind of work are you doing that might improve 5G over time?
That's a great question. So I think, well, 5G is here now. We already have it's kind of interesting. So 5G, from my viewpoint, is really two very different type of networking and wireless communication sort of architectures that are beginning to be melded together, right? So you have like sort of the evolutionary step. You take 4G, you take the sort of cellular type of architecture, and now what's happening is it's evolving. Now it's becoming a lot faster. It has better spectral efficiency, better sort of access to, let's say, service access to folks around, let's say, the G node B. It used to be E node B in 4G parlance, right? But then at the same time, there's this thing on the side called Internet of Things, which a lot of people are talking about. And that's the revolutionary step, right? In this sort of like a evolution of these technologies, like from 1 to 2 to 3 to 4, and now 5G. So right now, the work, the way I see it, is you have this sort of cellular evolution, and that's on target, like in terms of like people making it faster, more reliable, higher capacity. But now you have this sort of additional technology that's swooping in. And that's where I see a lot of work is happening. So that's one place is the IoT space. So that's happening and trying to make your home smarter, your city smarter, your road smarter, all that jazz. But at the same time, there's also the millimeter wave, right? And that's also swooping into this and is not really traditionally part of the sort of cellular architecture. And so you also see people who are talking about the sub-6, and you're talking about people with the millimeter wave, right? Like the 30, the 60, the 70 gigahertz folks, right? And the backhaul networks in particular with that technology. Of course, some people are talking also about with IoT that it would also operate in millimeter wave because of the high data rates that can be achieved over very short distances. But of course, people have also looked at, and millimeter wave is nothing new. I worked with millimeter wave 15 years ago, and the technology is about the same. There has been a lot of improvements to make it more reliable at those frequencies, because one of the big kickers in millimeter wave frequencies is rain absorption and rain fade. So really, like there's all these different technologies that are all kind of cobbled together with 5G. And I think what we're seeing right now is people trying to harmonize all of it. Especially since already there's been talk and murmuring about 6G. And that's the other one. Like right now, we see higher data rates, we see higher capacity, we're beginning to see IoT, we're having backhaul networks. But my big research activities in cognitive radio and machine learning, which is sprinkled throughout all of this technology, but hasn't really taken off in a really big way yet. And everyone's talking about 6G as being the cognitive radio G for this sort of cellular evolution that will be built on top of it. So that's, and of course, the other thing about 6G is everybody's looking at cranking up the carrier frequency well up to like 160 gigahertz and beyond as well. So that's kind of the landscape where a lot of things are trying to improve right now. I know, I'm sorry. That's not a very short answer, but so the idea is there's a lot of things happening. It's great that we're starting, but there's a lot more that can be done. And of course, we have in about 10 years, the next G to worry about.
So what are people doing in the IoT space? And the reason I ask is I expect there to be a large contingent of engineers who are going to be developing products to connect to the 5G network. And I think that's going to come particularly in the industrial space. And now that release 16 is done, that helps to solidify that. So what sort of work is being done to connect devices to the to the 5G network?
Okay. Well, I mean, IoT is although there's like industrial IoT, right? And there's a lot of work going on there. And just by itself, like that's not a small feat. Like the environments in these factory floors and manufacturing, especially sensitivity to latency and such, makes building an IoT network for an industrial setting very, very challenging, right? But it's not the only place, right? There's also vehicular IoT, or where the road itself becomes a smart road. It follows cars. It sort of like follows a whole stream of cars and adapts the road conditions to it. Like let's say stoplights, or let's say passes messages along to other vehicles about the presence of things like black ice. But there's also things like, for instance, agricultural IoT. In fact, I have two visiting PhD students from Senegal, from Université de Gaston Berger, and they are 100% in the game of IoT, especially for agriculture, like in this case, irrigation. And the reason there, because of the climate change that's occurring, Senegal used to have 2 growing seasons. Now, because of climate change, they only have 1, and they have to be really smart about it, how they irrigate their crops. Otherwise, they might not even have 1, right? And so IoT is a really critical technology in that. Now, how does it work over there? Well, it's got to connect to a 5G network, right? Because they don't have any sort of legacy information infrastructure. Everything. So whatever sort of the latest technologies that the country and the service providers can provide to purchase and stuff, that's what gets installed in the field. And now what they need to do is they have to have this network that has to do a lot of monitoring, everything from like measuring the amount of moisture in the soil to the amount of sun. And you also have, and this is a critical aspect of IoT, is things like the longevity of the finite power supply, the battery that's on each one of these IoT devices. So it's got to be able to connect to the 5G network. It's got to collect data, but it doesn't have to collect it too frequently because then it uses battery life. And then you have a whole ton of these devices. And hey, how are they going to connect to that 5G base station? Well, there's a number of IoT communication standards out there, like LoRa, NB-IoT, and several others, and each of them have their pros and cons. And that's just one example. That's like literally a life or death situation in some of these countries where they really do depend on telecommunications technology in order to support things like their agricultural industry. But the idea is having an industry where we can manufacture things really economically, safely, to specific requirements in an automated fashion. And then imagine the wireless environment that we're operating in, especially if there's like extreme temperature changes, if there's a lot of shielding, and it's rather difficult to get a hold of a whole different bunch of devices, a bunch of manufacturing equipment, robotic arms and they all have different, let's say, bandwidth requirements, latency requirements and such. And they too can connect to, say, a 5G network, which might be sort of the aggregator of the data as well as sort of the disseminator of instructions to the entire industry plant in order to manufacture a whole bunch of, let's say, cars or TV sets or whatnot. So IoT is going to be very critical in the years to come. And that's just two scenarios. Obviously, there's aging infrastructure, let's say structural health monitoring, environmental health monitoring, which is kind of like a variant of agricultural IoT. And then the vehicular networks, where we're trying to build smarter roads, right? And that's going to tie in very much, very much with the autonomous vehicle market, where right now, in my opinion, it's great that we have all this technology like LiDAR and radar and vision systems, but it's kind of hit a plateau in terms of advancement until it can make the next jump to sort of a sixth sense between the vehicles, sharing information in order to really have crystal clear situational awareness and make them safer than how humans could drive them.
You mentioned that you had 2 graduate students from Senegal
Yep.
working on this project. What other projects do you have going on, with your graduate students? And I know that WPI has always been, I consider WPI to have been the leader of undergraduate project-based education. Are you doing anything with undergraduates, or is it just graduate work at this point?
So my team, so all my students, both undergraduate and graduate, so everything we do in my team, it all has to do with sort of next generation wireless communications, right? It manifests itself in a lot of different activities that involves things like, for instance, the senior design capstone projects, independent study projects for the undergraduate level students, as well as master's theses, PhD dissertation research, and visiting scholars such as the 2 PhD students from Senegal. In terms of cognitive radio, all my students focus on some different aspect of cognitive radio. So for instance, I have one student that is really looking into machine learning in order to make a much smarter radio, that's capable of taking the environment around it, all the situational awareness that it sends, in order to make decisions on the fly, right? So that's one student. I also have 2 students that are looking at vehicle networking, right? Specifically vehicle to vehicle. And they're looking at everything, like, for instance, they're looking at, when you think of cognitive radio, a lot of people say, oh, human cognition, but not necessarily that's true. In fact, what my students, like that student is actually looking at is, in collaboration with several biology professors, we're looking at using bumblebee behavioral models in order to model the cognition in a cognitive radio in order to access wireless spectrum. I also have another student, PhD student, and what she's doing is she's looking at cognitive radio in order to facilitate beamforming between 2 vehicles that are autonomous in order to adaptively communicate in an autonomous vehicle fleet. This would make a lot of sense in the future when we have, let's say, platoons of autonomous vehicles, or autonomous vehicles operating in the same streets as human-operated vehicles. And then, of course, at the undergraduate level, I have students that are building 5G base stations in my research lab. I have students that are doing Internet of Things connected to 5G base stations in my research lab. And then at the same time, I have students that are looking at things like Bluetooth, which is maybe not cognitive radio-like, but is kind of a critical element in things like Internet of Things. But in general, the theme that a lot of my students and what they do in terms of the work, there's a lot of cognitive radio, there's a lot of IoT, there's 5G, there's a few students that do SATCOM, right? Satellite communications. And ultimately, sort of the theme throughout my research lab is that we not only do sort of theoretical work, but we also build. We do proof of concepts, we prototype using a technology called software-defined radio. And that's a technology that has evolved quite rapidly over the past 15 years, where I can build a 5G base station in my research lab and already do experiments on 5G, and kind of push the state of the art, which is great, because that's what universities are all about. Create new knowledge and disseminate it.
You mentioned that some of your students are are building or looking into IoT devices to connect to 5G.
Mhm.
What are they using in terms of components or other products that are maybe available on the market to connect to 5G? For example, are they trying to build their own RF chain, or are they using a chip from one of the chip makers who tend to sell to the cell phone companies? So how are they doing the connection?
So what a lot of my students do in terms of the sort of connecting, first of all, like the IoT devices, the IoT protocols that my students are implementing. So for instance, one set of my graduate students, what they've been doing is they've been using a product from France called PyCom. And that actually supports 4 different simultaneous IoT standards on the same chip. So it supports LoRa, it supports Bluetooth Low Energy, it supports Sigfox, and I think it supports Wi-Fi. So that's not really IoT,
Mhm.
but it's nice to have anyway. Um, and then I have another undergraduate team. What they're trying to do is they're trying to use something like a PyCom, but I suspect they're probably just going to do LoRa directly. And what they want to do is they actually want to take the LoRa device, communicate to a base station that accepts all these LoRa communications, and then interface it, in this case, to a custom-built millimeter wave backhaul network that would then relay that information from that IoT network back to some sort of centralized sort of repository or a data processing center. So there, it's not actively using like a 5G base station. I do have another student team that you can build. There's software out there called, for instance, there's one open source project called OAI, or Open Air Interface. This is from Eurocom in France, and so you can actually build on a software-defined radio your own 5G base station. I had last year's team, student project team I had, they actually built a 4G base station using OAI. And what you could do is you could actually connect 5G cell phones to that software-defined radio that's built as though it's actually a 5G base station. But none of my students are doing that, the IoT directly to a 5G base station. They're looking at more sort of the melding of 2 completely different wireless transmission technologies, because ultimately what you're going to have is you're going to have technologies of completely different latency thresholds and completely different data rates that are going to be interfacing with each other, and that's going to be very challenging, especially since because they have different requirements. How do they mesh together? And that by itself isn't sort of a great educational experience. So you have these IoT devices, their data rates are maybe megabits per second at most. And then you interface that with a 70 gigahertz relay backhaul link that is capable of transmitting at 1 gigabit per second. So how do you mesh those 2 technologies together, taking information away from the IoT network to feed it ultimately to some sort of central processing center, and then pushing information back out to the individual IoT devices? And especially if there's any sort of issues with like latency or resource management, because of like how you're like taking these individual relatively low data rate streams and melding it into 1 gigabit per second stream that goes by millimeter wave back to back to the office, if you will.
You mentioned millimeter wave a few times.
Oh yeah, yeah.
How
That's
how
another
are
part.
you testing these millimeter wave devices? What do you have available?
I've been setting up, due to the pandemic, I actually set up here at home a small millimeter wave test bed that my students can remotely log into. And it's actually been kind of interesting. So what happens is, what these millimeter wave boxes do at 70 gigahertz, they effectively form 1 gigabit per second wireless links. And then part of the work, so one student is setting this all up, right, to create a millimeter wave relay, if you will. And then another undergraduate student project team is trying to create an IoT network at the end of one of these and see for themselves what would happen if you have all these different IoT devices that send data to a node that then says, oh, okay, takes that information and then sends it by over a 70 gigahertz channel to another relay that ultimately relays it, in this case, to a computer in my basement. And so the educational activity there is really kind of determining the feasibility as well as any issues with respect to things like latency and these sort of really different data rates that are involved in this technology.
You have a millimeter wave lab in your backyard.
Yep.
Well, I'd love to hear about that, but I think that's going to be a story for another day. Professor Alex Wyglinski, thank you very much for taking the time to speak with us. And I look forward to hearing about your millimeter wave lab in the backyard.
Thank you, Martin. It's a pleasure.